Ever wonder if we are trapped within our own dimensions, ignorant of the vastness that lies beyond? Picture this, a line of ants, each following the one in front, moving along a straight path. This is a one-dimensional world, a mere line where the only options are forward and backward. Now, imagine a sheet of paper bearing doodles and drawings, a world of two dimensions where up, down, left, and right come into play. Then, think about a box, a cube, a sphere. These exist in three dimensions where depth is added to the mix. We live in this 3D world, aware of the up, down, left, right, forward, and backward. But we also exist in a fourth dimension, time. Observe the progression of a day from dawn to dusk, the ticking clock, the shifting shadows, the sequence of events. But what if there was more, dimensions that our human senses can't perceive? Imagine a world where you could see all sides of a box at once. A world where up, down, left, right, front, and back are merely the beginning. This is the realm of higher dimensions, the fifth dimension and beyond. We live in a three-dimensional world. It's all we've ever known. But what if there's more than meets the eye? Let's consider a tesseract. It's a four-dimensional analog of a cube, much like a cube is to a square. If you've ever seen a representation of a tesseract, it might seem like some sort of optical illusion. A cube within a cube, connected by lines that seem to defy the rules of perspective. That's because we're trying to project a four-dimensional object into two dimensions. It's a bit like trying to draw a cube on a piece of paper. You can give the impression of depth, but it's not quite the same as the real thing. Now, extrapolate that to 5, 6, 7 dimensions and beyond. It's difficult, isn't it? Our minds, so used to 3 dimensions, struggle to comprehend these higher dimensional spaces. But just because we can't visualize these dimensions doesn't mean they aren't there. Enter string theory. This theory, born out of the quest to reconcile quantum mechanics and general relativity, posits that the fundamental constituents of reality are not zero-dimensional points, but one-dimensional strings. And for the mathematics of string theory to work, it requires the existence of 10 dimensions. That's right, 10. 6 dimensions beyond our familiar 3, curled up so small that we can't perceive them. But what does it mean, really? Are these dimensions just mathematical constructs, or do they have physical reality? Could they be the key to understanding the nature of the universe, the mysteries of dark matter and dark energy, the enigmatic force of gravity? These dimensions, while unfathomable to us, could be as real as the world we live in. And just as we once thought the Earth was flat, perhaps one day we'll look back and marvel at how we ever thought the universe was merely three-dimensional. What would it mean for us if these higher dimensions do exist? Just imagine for a moment. The existence of higher dimensions could fundamentally alter our understanding of the universe. They could be the key that unlocks the door to new realms of physics, reshaping our view of reality itself. Let's take a trip into the realm of the theoretical. In the vista of higher dimensions, the laws of physics as we know them might not apply. They could offer solutions to some of the greatest paradoxes and mysteries in science. The elusive dark matter, the enigma of quantum entanglement, the mystery of black holes. All these could potentially be explained by the existence of higher dimensions. In the world of quantum mechanics, for instance, particles can be in 2 places at once, and they can spin in opposite directions simultaneously. These puzzling phenomena, which seem to defy our everyday logic, could make perfect sense in higher dimensional space. And then there's string theory. This theory suggests that the universe consists of tiny, vibrating strings of energy existing in multiple dimensions. If higher dimensions do exist, it could provide the framework for a unified theory of everything, harmoniously merging the world of the very small, described by quantum physics, with the world of the very large, explained by general relativity. Higher dimensions could even have implications for the concept of time. If we consider time as a 4th dimension, what if there are more temporal dimensions out there? Could we then move forward and backward in time, just as we can move right and left in space? However, it's important to remember these are all theoretical musings. We have yet to find empirical evidence of higher dimensions. But the mere possibility opens up a universe of questions and potential discoveries that could radically change our perception of the cosmos. The existence of higher dimensions could revolutionize our understanding of reality. It could be the dawn of a new era in our understanding of the cosmos, pushing the boundaries of human knowledge and exploration. Are we on the brink of a dimensional revolution, or is this just theoretical whimsy? The answer to this is as elusive as the concept of higher dimensions themselves. The current state of research and exploration into these dimensions is a captivating blend of hard science and imaginative philosophy. At the heart of this exploration, we find some of the brightest minds in physics, mathematics, and cosmology, all wrestling with the theoretical implications of higher dimensions. They're using complex mathematical models, quantum mechanics, and string theory in their attempts to peel back the layers of reality and reveal the unseen dimensions that could lie beneath. Yet, for all their intellectual might and technological prowess, these explorers face a daunting task. The challenge of proving or disproving the existence of higher dimensions is immense. After all, we're trying to comprehend realities that our human minds, evolved to navigate a three-dimensional world, find inherently baffling. Imagine trying to explain the concept of up to a two-dimensional being, a creature living on a flat plane. That's akin to us trying to understand the fourth, fifth, or even 10th dimension. We're grappling with notions that defy our everyday experiences and intuitive understanding. Moreover, we currently lack the technological tools to directly observe or interact with these higher dimensions. We can't just build a spaceship and sail into the fourth dimension. We can't design a microscope that lets us peer into the fifth or sixth. These dimensions, if they exist, are beyond our current capability to detect or measure. Yet despite these challenges, the exploration continues. The quest for knowledge, the insatiable human curiosity, drives us forward. We continue to question, to ponder, to theorize. We keep looking for clues, for patterns, for anomalies that might hint at the existence of more than our familiar three dimensions. As we stand on the edge of our dimensional understanding, we can't help but wonder, what lies beyond? What new insights could higher dimensions bring? What new realities might they reveal? The mystery continues, and the journey, it seems, is just beginning.